In this video, I'd like to talk some more about the way variables work in Python. You've seen variables before. Let's create a variable called a, and we assign the number 3 to it. Next, we create a variable b, and we assign the value of a to it, which would lead b to become 3, obviously. But let's check if that's really the case. Print b, I'll run the program, and there you have it, it prints 3. Now, what happens if later on we change a to 4? Would you expect b to change? No, of course not. B would still be 3. Which makes sense because the program is just running line by line. So here it's assigning 3 to A, here it's assigning 3 to B, and here it's assigning 4 to A, but B is still the number 3. Nothing special going on here. Now, when we look at lists, something a little bit weird can happen, or at least it can be weird when you first learn about it. So let's create a list containing 3 items, and then I assign the list to B. Well, let's print B. Let's verify that it is indeed 1, 2, 3, and it is. Alright, nice. And now what would happen if at this point we were to append an item, the number 4, to this list, to A? Would you expect B to change now or not? Let's see what happens. 1, 2, 3, 4. So B actually changed while we said a.append 4. Why is this happening? If you already understand why this is happening and this is logical for you, there's no need to watch the rest of this video. If not, keep watching. What's happening here is that in this line, in line 3, there are actually 2 things. The first thing that happens is that a new list gets created. It's a list and that now contains 3 items. This list will be stored in your computer's RAM memory somewhere, and it will remain in that same location for the duration of the execution of the program. The variable a will it gets assigned this list, but it doesn't get a copy of the list. No, it will actually have a reference to this list. So there is this list, and now a is referring to this list. It's pointing at that list, so to say. In the next line, we're not creating a copy of the list. Instead, we're creating another reference to the same list. So the list that gets created here and has one specific memory location in your computer, it's now referred to by A and by B. So A and B are now pointing at the same list. There are not 2 lists, no, there is still one list, only there are 2 variables that both point at the same list. So what happens when we say a.append 4? Well, the one list that we have gets extended. It grows and it adds another item. So if it doesn't matter if we're accessing it through A or through B, it will lead to exactly the same result. That happens when we're modifying the same list, right? So another way to modify a list would be to access one of the elements, right? So in order to access the middle element and to change it into something else, we could do this. And again, we're only modifying this list, so we would expect B to change to point at the modified list. So let's see what happens. There. Exactly as predicted, the one list we have was modified here through A. And of course it works the other way around too, right? So if we're modifying it through B, and we're printing A, well, actually we're still referring to the same list twice. So this would lead to the exact same result. One thing to keep in mind is that this only works while we are changing the list that we created here. If we are assigning a new list to B instead of changing the existing list, then that won't have any consequences for A. So let's say we're saying now B is 4, 5, 6, At this point, we're no longer changing this list. No, we're creating another list. So B will be referring to this list, and A will be referring to the list we created earlier. So when we're printing A, it will still have the value that it had initially, 1, 2, 3. There. So at this point, A and B really are different lists. Even if we append something to B, it doesn't matter to A at all. I hope that makes sense. If not, play around in the console or play around in a little program. See if you can get a grip on how this works. The same thing applies for working with functions. Well, let's say we do have a list A, and we're creating a function. What should it do? A function that appends an item. And it receives a list to work on. Now, list wouldn't be such a good variable name because it's also a built-in function. So let's call it our list. And what would happen if we run append on this list? So let's move this around a bit. So we have list A, and then we call our function append an item, and we pass it A as the list to work on. So within the scope of this function, our list would get the value of 1, 2, 3. Would it actually be the same list? Would our list be referring to the same list as A is referring to outside the function, or would it get a copy? Well, let's test. So let's see if A actually was modified here. And as you can see, it was. So what this means is that when you're passing an argument to a function, it's not actually making a copy of our list. No, it's just passing a reference. It's pointing at the same list that was created here. It's not creating another copy. It's not creating another list. No, our list and A are both pointing at the same list. We only have one in this program. What do you imagine would happen if we were to change our list to something else entirely? Well, maybe another list, A, B, C. Try to answer the question. What would happen now? Let's run it. As you can see, the program still returns 1, 2, 3, 1, 2, 3, 123. So this did something. This did change the variable A outside of the function, but this didn't do anything. Does that make sense? Well, actually, it makes a lot of sense, because our list is actually a parameter to the append an item function. It's a parameter, which means it is a local variable. And local variables, they don't have any changing them doesn't have any effect on variables outside of the scope of this function. So when I'm changing our list, I'm just changing something within this function. And on the line after this, the function ends. And at that point, all of the local variables, in this case only our list, will be deleted. They won't exist in memory anymore. So what we did here is we created a new list, and we're assigning that a reference to that list to our local variable. But that doesn't change whatever list A is pointing at. A is still pointing at the list we created here. So while executing this program, two separate lists are created. The first list is created here, and then when we call the append an item function, a second list is created. And at this point, our list will point at the second list, but A will of course not have changed. It will still be pointing at the original list. So that and because our list at this point was still pointing at the original list got modified, as we can see here. I hope this clears things up. If it does not, please keep at it. This is something you really should understand, otherwise you run into weird problems. So try to play around, try to see if you can really grasp what's happening here, if you can predict what Python is going to do. If you can't figure it out, ask someone for help until you do. It's not that difficult, only it requires a little bit of thinking differently. Good luck.